numerator and denominator. For example, half. This is a number smaller than 1 and greater than 0. Okay? It's between 0 and 1. Half, 1/5, quarter, third, 1/6, 1/8, 1/10, whatever. If the numerator, this is called numerator, and denominator, if the numerator is smaller than denominator, this means the number or this fraction between 0 and 1, greater than 0 and smaller than 1. Okay? And this is called proper fraction. Proper fraction. If it is, for example, 3/2, the numerator is greater than the denominator, this is called improper fraction. Improper fraction. And this improper fraction means it's greater than 1. Greater than 1. Why? Because 2/2 equals 1. Okay? And this is 3/2. It means it's 1 and 1/2. It's 1 with this 3. So 3/2 means 1 and half. 1, 2/2 equals 1, and the remainder is 1/2. So this is this number is, or this fraction is greater than 1, and this is called mixed number. Mixed number. Mixed number because it consists of a whole number and proper fraction. A whole number and proper fraction. Both of them together is called mixed number. Okay? Okay. Here I have 1/2 and 1/3, and I want to compare between them. The numerators are the same. The numerators are the same. And the denominators are different. So, which one is the greatest and why? Half means, if I want to represent it by graph, it will be by this shape, and this third. This is 1/3 and this is 1/2. Which part, which shaded part here is the greatest? Of course, this one. This one is the greatest one. So, half is greater than third. Okay? In the other side, let's be 5. Here, the numerators are different and the denominators are the same. I draw here the graph. 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. Okay, here 3, 1, 2, 3. And here the same shape. denominators are different. So, if the denominator is less than or the smallest, okay, that means this fraction is the greatest one, okay? Again, if the denominator is smallest, okay, that means the fraction, the whole fraction is greatest than or greater than the other one, okay? But here, if the denominators are the same and the numerators are different, so that means I deal with the fraction as a whole number. Again, if the denominators are the same, I deal with the fractions as whole numbers. 3 is smaller than 4, so 3 over 5 is smaller than 4 over 4. Okay? Good. So, these are the two rules. You have to know them very well. Okay. What if they are different? What if they are two fractions, their denominators and their numerators are different? For example, 2 over 7 and 3 over 9. 2 over 7 and 3 over 9. By the way, you can simplify this fraction. If you want, you can simplify it to be easier for you. So, I simplify it. So, it will be 1 over 3. Okay? And I'll deal with them. I'll change the color. I deal with it, okay, by scissors, okay, 3 times 2 equals 6, and here 7 times 1 equals 7. So which one is the greatest? 6 here. Here I convert them to a whole numbers. This is 6 and this is 7. So, 6 is smaller than 7, so this fraction will be smaller than this one. 2 over 7 is smaller than 1 over 3. Again, another one. Here we can, I'll change it. You can simplify it. Make another one. 4 over 5 and 5 over 8. Okay. I make scissors. 8 times 4 equals 32. And 5 times 5 equals 25. So, which one is the greatest? 32 is greater than 25, so 4 over 5 is greater than 5 over 8. Okay? I think it's very, very, very simple. Okay. The fraction as a graph. Here, a decimal number 3 over 8 and 0.5. You can convert from decimal number to fraction. So this will be half 1 over 2 and the scissors. The two rules that we said. Okay. Here, if you want to rearrange ascendingly. Ascendingly means from the smallest to the greatest. 7 over 18, 5 over 18, 1 over 18, 25 over 18, and 13 over 18. Here, all the denominators are the same, so we deal with the numerators as, or the fractions as a whole number. So here, what is the smallest number here, or smallest fraction? Here, the 1. So this is the smallest one, the first. Whereas the second, 5, then 7, then 13, then 25. So this would be the arrangement of them, or the order of them. Okay, here another one, but descendingly. Means from the greatest to the smallest. Find the possible values of x which satisfy the following relations, where x is an integer. Okay. Here, 4 over 7 is smaller than x over 7, smaller than 8 over 7. That means x over 7 is between 4 over 7 and 8 over 7. Is greater than 4 over 7 and smaller than 8 over 7. So we can write x can be 5, can be 6, or can be 7. Okay? Any one of these three is right. Any one of them is right. 5, 6, or 7. Here. 5 over 8 is smaller than 5 over x. Okay? It's smaller than 1. So, here, I want to get the value of x. If I write 5 over 5, okay, it will be wrong. Why? Because this fraction is smaller than 1. So I can't write here 5. And if I write any number smaller than 5, okay, it will be improper fraction, so it can't be. So I write here 5 over 6, okay, 5 over 6. Goes 5 over 6 or 5 over 7. So here the correct answer is 6 or 7. 6 or 7. 8 will be the same, and the two fraction will be the same. And if I write 9, 10, or anything greater than this, greater than 8, it will be, this fraction will be smaller than this one. But I know I want this one to be greater than this, so it will be 6 or 7. 6 or 7. Here, for comparing two fractions with different denominators, sorry, not different denominators, we said them. Different denominators or here, different denominators or different numerators. As we said, we make scissors is the most easier one. Okay. Another way to get the LCM not LCD, LCM. LCM means here I want 3 over 5 and 4 over 7. LCM, it means I want to unify the denominator. I want to unify the denominators, to let them the same, to let the denominators the same. Okay, so 5 and 7, both of them are different. I multiply both of them together. I multiply them together. 5 times 7 equals 35. convert from fraction to decimal, okay, 0.5 and 0.2, so 0.5 is greater than 0.2. Or, if you want, you can say 0.2 means 2 over 10. You can convert from decimal to fraction. It will be the same, 2 over 10. Then, compare between 1 over 2 and 2 over 10. Okay? Also, of course, half will be greater than 2 over 10. Okay? Okay. Here, 4 and third. And here, 4 and 2 over 7. Okay. This is 2 mixed numbers. This is 2 mixed numbers. If the whole numbers are the same, so I compare between the fractions to know which one is the greatest. Okay? So it will be very easy if the whole numbers are the same. So I deal only with the fractions. Third and 2 over 7. By scissors, I prefer this one. 7 times 1 equals 7. 3 times 2 equals 6. So this one is the greatest one. So 4 and third is greater than 4 and 2 over 7. Okay? Don't confuse if you see mixed number, if you see decimal, if you see improper fraction, okay, you can convert, if they are different, you can convert one of them to be like the other and compare between them easy. This is of course half, quarter, third, and you can arrange them ascendingly. Quarter, or 1 over 4, then 1 over 3, then 1 over 2. This is the same. You will to write the fraction, of course, to refresh your mind, you will count the shaded parts, okay? Be the numerator over the whole square, the whole number of squares, and this is the denominator. Okay? Here, for comparing and arrangement, it's very easy. Here, find the value of A, B, and C. Okay. I want the A is the unknown number for me now. Okay, I see 5 and 15. 5 becomes 15 going by multiplying by 3. So I multiply 2 by 3 also, so it will be 6. So 2 over 5 equals 6 over 15. Here. 24 becomes 8. Okay. Here I made the opposite because the unknown number is here. Okay, so I want to know it. How can I get it? So 24 becomes 8 by divided by 3. Okay, so 15 I also divided it by 3. It becomes 5. So B here equals 5. Here I want the value of C. So 2 becomes 16 by multiplying by 8. So here I multiply 3 by 8, so it will be 24. C equals 24. Okay? The arranging. So I think the lesson is very easy. I hope that you